have Matt Hamilton. I think he's working on IBM.
Yeah.
Yeah. Oh, well, let's thank him for coming.
Right, hello. So yes, my name is Matt Hamilton. Quick little bit about me. This is following on the theme, it seems to be, of this evening of fun things that we did that sort of worked and sort of didn't work, but we did because they were cool. And this is kind of a learning exercise. So just to frame this, I've been a Python developer for 20 years, but mainly web stuff. Those of you that have been around the Bristol web scene will probably know me from running NetSite and dealing with OpenPlone and stuff like that. But I discovered Pandas last year. Where have you been all my life? Pandas is fantastic. I love it. I think it is, killer library for Python. I work for IBM, but not actually doing anything to do with their AI or ML stuff or big data or anything. I'm actually an engineer in their cloud database team, so I'm the layer below, storing all of the crap that you guys are uploading to do ML and AI on. So this is just a personal sort of side project and nothing official from IBM or anything like that. I have a personal interest in cryptocurrency and trading, and so what happened was about a year or so ago, ex-colleague of mine gave me some cryptocurrency. I was in between sort of jobs and was looking for something to do, so was skilling up on stuff and thought, I'll get into some big data stuff and play around with it and that. So as we know, that's where we end up with cryptocurrency. That's the end goal. We're all going to be rich. A lot of people try to study the charts. This is what's called a candle chart. And there's a lot of people called chartists that kind of take this stuff as gospel and talk about, double shoulders and hanging doji and all sorts of patterns that are in there, and go and draw lines all over it. And I think it's a little bit like reading tea leaves. I'm not entirely convinced, especially in very immature markets like cryptocurrency. The cryptocurrency I'm a big fan of, XRP, shot up about 15% today in the space of an hour and jumped up about 20% a few days ago in the space of an hour. So, you can do all of this and think you've got everything, and then it just all gets blown out of the water. So I'm looking at, this is a sort of a trading view, and the bit circled on the left there is the order book. So this is who's trying to buy and who's trying to sell and at what price they're offering. So I'm offering to sell this currency at this price or this stock at this price, and I'm looking to buy at this price. And in the middle is kind of where they meet. And down the bottom, this is a sort of a cumulative graph of how much is being offered on each side, and most of the interesting stuff happens in the middle there. So Frank gave a talk at an IBM thing a few weeks ago and showed something about predicting traffic stuff and rivers. And previously, I'd been looking at trying to use sort of AI and ML to kind of analyze this stuff. But it's all manual feature extraction. What am I looking at for a feature? Am I looking at the height of the candle relative to its predecessor, the little line at the top called the wick and how high that is? There's all these sort of things there. Whereas instead, I took inspiration from what Frank had done and tried to sort of visualize this, plot it, and then see if I could throw it into a convolutional neural network. So each one of these images represents 180 seconds across. They're 180 pixels wide, and represents the order book, the buys and the sells. So as you go towards the top, that's the darker green is a larger cumulative amount of people willing to sell stuff at a different price. So each one of these, we're going about, I think it's about 0.1% either side of the minimum, mid-price point here. So a sale at the top would be somebody's really, premium, really wants to buy it. The blue lines are where sales actually kind of occurred. So each one of these is a snapshot, and I thought, okay, so the question being is, given that 180 seconds, could we predict what the price would be like in 10 seconds? That's the kind of time scale I'm looking at because, like I said, random events and it goes blown up all over the place. So let's just concentrate short term. Can we do this? Since I'm working at IBM, playing around with Watson, IBM Watson, we've got a visual image classifier. And it's got some pre-trained models, general model, food, face detection. So I created one, an order book classifier. And all you have to do is literally upload zip files. So I created 3 classes, down, none, and up, which represents the price going down, the price staying level, or the price going up. And literally, you just upload a zip file with a bunch of images. So these images here, I had several hundred of them, 1,000 of them, whatever. I just dumped it up and said, go. And it goes away and it comes back about 10 minutes later and goes, I've got a trained model. And you can drag and drop an image onto it. It goes, we think this is down. And amazingly, just sort of dragging images onto it, it got them mostly right. And I was like, this is unbelievable. This is amazing. I can't believe that. That's actually sort of working. Because I only have a certain number of requests I can do against Watson before they start charging me, I didn't go and hit it too hard with the Python API to go and run it properly. So I tried to replicate it in Keras. I was meant to be at the workshop, but unfortunately due to bad planning and a fight with Google Maps, I didn't make it. Yeah, I tried to replicate it. This is kind of what my thing looked like in Keras. I've messed around with it. The answer seems to be, like I said, I'm new to ML. The answer in all cases seems to be just try stuff. So that's what I did. At the end, I was getting about 50% accuracy, which doesn't seem very good. This was the confusion matrix. But what was interesting was when we actually predicted the price was going to go up, about more, it did go up most of, a lot of the time. So if you think, if that was predicted that it's going to go up, and we make a trade thinking it's going to go up, well, 44 times it went up, only 27 it went down. If we discount the sort of the middle bit where it didn't do anything, because we could say, well, that's not a bad result. We only care whether we actually go up or down, then we're still actually getting some results there. I actually screwed it up. That is actually the fixed results, but I screwed it up beforehand, and that I actually managed to leak data, did the classical ML thing of actually leaking data. So what Watson was actually trained on probably is actually slightly wrong, and there is some data in there that is giving it some hints that I think it's picked up on. But even so, even with it fixed, it still seemed to actually be that there could be something there. So future of this experiment, how far back should I be looking? 180 seconds was a guess. Do I want to be looking at like the last 5 seconds or the last 10 minutes? How far ahead do I want to look? Should I literally be looking, the resolution I'm capturing this in is every 100 milliseconds. So I could be looking at what's really immediately going to happen. Effective pooling layers. Convolutional neural networks, you have these pooling layers. From what I understand, the idea, one of the advantages of them is that they reduce the positional dependency. So this is a dog. It doesn't matter whether it's a dog up here or up here in your image. In my images, it might be very interesting. It might be very important that this feature happens in this place. So anybody who knows anything about that, please give me some advice. Still have no idea what I'm doing there. I was looking at things like MRI scans. How do MRI scan ML work? Is that interesting? Additional data on different channels. I've got other stuff. That's a plot of every time an order is added to the order books. So I've got whenever it's added, whenever it's deleted, so I can see activity of other trading algorithms. So I'm not quite at the yacht stage yet. Still playing around, having fun though. So there we go. Thanks a lot.
Well, thanks everyone for coming, and thank you for all your energy, for offering all this